Okay, so we have the equation y is equal to 5x squared minus 14x minus 13. Now I purposely put the order in this manner, right? Axis of symmetry, you don't actually need the quadratic formula for. Shortcut to that. Do you guys remember what it was? Axis of symmetry? I introduced it when I proved the quadratic formula. I paused and said, what do we notice? We had x minus something only squared during that proof. Right? Axis symmetry you can get by x is equal to minus b over 2a. Okay? So let's just take a step back. So we have an equation that's in standard form. So what's your a value?
5.
A here is 5. B is negative 14. And C is negative 3. Okay? So our axis of symmetry really is x is equal to minus, B in this case is negative 14, all over 2 times A. What's the value of A is 5. So we really have x is equal to 14 over 10, which is equal to 7 over 5. So you guys got it?
Yeah.
Okay. So I mean, that's all you're looking for, axis of symmetry, right? You don't need to use the full quadratic formula to get your x-intercepts and then take that divided by 2, right? Which some of you might have done, I'm not sure, right? So if we have the x value, how can we get our vertex? We just sub that into the equation. So y is equal to 5 times 7 over 5 quantity squared minus 14 times 7 over 5 minus 3. So y is equal to 5. 7/5 squared is just 49 over 25 minus 14 times 7, 98 over 5. So I realize I'm going to be dealing with fractions here. I'm going to convert the 3 into negative 15 over 5, right? Here I could reduce my 5's. So I just get 49 over 5 minus 98 over 5 minus 15 over 5. So what's y is equal to? 49 minus 98 is negative 49 minus 15 is minus 64 over 5. Did I answer the question?
No.
No. Some of us in the summer, maybe not nobody in this class, but they just figured out the y value for me. That's not telling me what the vertex is. Okay? Therefore the vertex is 7 over 5 and minus 64 over 5.
Could we not use a quadratic formula to figure this all out?
We could. So I mean, if you were only asked to find the axis symmetry and the vertex, all you need is this part of the quadratic formula minus b over 2a, because that tells you axis of symmetry, and then you plug that in.
But
So if you use the quadratic formula, what does that get you? That gets you the x. That gets you the zeros.
then if you get the middle of that, or like
Exactly.
that gives you the axis of symmetry, and then you plug that axis of symmetry into the equation, and it gives you the vertex.
Yes, but this is a little bit shorter to get those two things as opposed to, well, let's do the x-intercepts. So let me do this.
On the test, do we need to know like why the quadratic equation is like that? Like,
Doesn't hurt.
so but is it a mark?
Doesn't hurt.
What do you mean? We need to know why.
For communication, how to explain
Oh.
Oh, nice.
it. You ever feel like
What is
a
smart
loser using a whiteboard?
Okay, so the quadratic equation again was
Tony Stark.
Negative b.
x equals negative b
Plus minus
plus or minus.
the square root of b squared
Yeah, go ahead.
minus
Don't
4ac
Just take that. Thanks, man.
That's it?
over 2a.
Oh my gosh.
And we review how this is made again, if it's gonna help.
If it doesn't hurt.
If it doesn't hurt, well, you can watch the video again.
Oh,
Right. If you look in section 6 of the homework, they actually had to do that themselves. They had to watch the video. I sent the links to Michael, but there's Khan also proved it as well.
The column
Right.
shorter, it's not 40 minutes.
We won't go there.
Ooh.
I watched the review for the, I thought like the lesson was the first half. It was the review from the class before. It was like
Oh.
20 minutes in, and it was like, okay, we'll start the lesson.
Okay, so minus b, so minus 14 plus or minus the square root. You know, the quadratic form is kind of boring because it's just plugging in numbers. It's a lesson on can you plug in the numbers, which some kids like because it requires no thinking. But it is what it is.
I think it's okay.
Minus 4, what's a is 5, and c is negative 3. All over 2 times 5. So we have 14 plus or minus the square root of 14 squared was
196.
196. 4 times 5 is 20, times 3 is 60, but that's a positive 60. All over 10. So x is 14 plus or minus the square root of 196 plus 60 is 256.
And 16.
Over 10. So yes, the square root of 256 works out nicely to be 16. So here we have x is equal to 14 plus 16 over 10, or x is equal to minus 14 minus 16 over 10. So 14 plus 16 gives us 30 over 10, which is the same as 3. X equals 3. And here we get x is equal to minus 2 over 10, which is x is equal to minus 1/5. So yes, from here, then you could, Christian, you could take half of those, right?
Dumbest mistake I've ever done.
See, that's the thing, right? If we plug in this formula wrong, right, which is lengthy, this is the drawback of the quadratic formula. It's pretty lengthy to get all these numbers going.
I reduced the negative 2 over 10 into negative 1 over 2.
So that's the drawback. So which might be simpler to get your axis of symmetry? Is using minus b over 2a, right? We kind of see where the minus b over 2a is coming from. It's over here, right? That tells us our axis of symmetry. Then we go from there. Okay, any questions on that? Straightforward, just plug in formulas. So hopefully in the homework, that's what you did. Wrote down the formula as well every time you did the question. That's how you get into here. Okay? Questions?
So for
Michael?
every question that involves a quadratic formula, we have to figure out like the vertex, x-intercepts, and the axis.
Anything about the quadratic formula just helps you find your roots or your zeros. Okay? However you need that information, you can use a quadratic formula.
What was the axis of symmetry?
7 over 5. Okay. Okay, we did this question already, I think. This is supposed to be my Walter thing. Okay, new question. The path, and this it's actually on your second page of the handout I just gave, so you don't have to write out the question, you can just work it out right on here. Okay. So it says the path of a basketball after it's thrown throw basketballs, right? I should change that question. We shoot it, right? We only throw bricks. We shoot basketballs. Although judging by some of the way the guys play, the other night, couldn't tell the difference.
Okay, there's
One in
basketball
14.
players.
Let's go look if there's any
I know,
basketball
there's
players
some
in this
basketball
class.
players,
You're all good. The path of a basketball after, so wait till my 10th this afternoon. The path of a basketball after it's thrown from a height of 1.5 meters above the ground is given by this equation. H is equal to negative 0.25 d squared plus 2d plus 1.5. Where h is the height in meters and d is the horizontal distance in meters. I should be specific, away from the shooter. Okay, so basically away from the shooter. How far has the ball traveled horizontally to the nearest tenth of a meter when it hits the ground? Okay.
It's a 0.
So first thing you do is word problem. Help us visualize it, draw a picture. Right? So here we have the ball. Right? This person
So,
shoots the ball.
It hits the ground. That
A
means they
pretty
didn't
high arc. Right? And it's gonna hit the ground, let's say here. Right? So this is where that's where it hits the ground.
score. So it's gonna be average. This is a
Okay. So this distance you know is 1.5 meters high. Do we almost kind of see where x-axis is?
wait. Is
Where's the x-axis going to be?
the
With H
where
and
he
Yeah, the ground, right? So here we're going to almost see like this is where x-axis is. And it makes sense because, or in this case it would be the h-axis. No, the d-axis. This is actually d. Since we're not doing x and y anymore, it's dealing with d. Right? So that's actually d. And it makes sense. What's the value of d? Sorry, what's the value of h when d is 0? We'll plug it in our equation. When d is 0, what's the value of h? Well, look at our equation. Negative 0.25 d squared plus 2d plus 1.5. When d is 0, so replace d with 0 here.
1.5.
Yeah, the value of h is just 1.5, right? D squared is 0. 2 times 0 is 0, right? So these things just basically cancel out. We just have 1.5. And that makes sense here, right? So a point, at this point, it's 1.5 meters high when D is 0. So this is h here. So how can we figure out
axis.
where it lands, how far away it
How
lands?
far away
You gotta find the x-intercept.
Why do you say that?
Because there's two x-intercepts, so one's gonna be negative, one's gonna be positive, so the one that's positive makes sense.
Yeah, so this is really an intercept, right? In this case, it's a c-intercept. Basically, we want to find the value when h is,
Positive.
no, when h is what? What's the value of h right here?
0.
0. We've done that several times as unit, right? While solving for something is 0, solving this equation. So basically, what we want to solve for is 0 is equal to minus 0.25 d squared plus 2d plus 1.5. Right? We want to find out when h is 0. That's what this spot here means when the ball hits the ground. When h is 0, what's the value of d? So we're going to do that. Factor it. Complete the square.
Quadratic form.
Yeah, this one, let's plug in the quadratic formula. I'm not even going to begin where I might try to factor that. First of all, it's in decimals, right? I could try to complete the square. It could be difficult. That's my point.
So the plus 1.5, will that always be the height that, for this case, the ball's thrown at?
That's the equation.
Always?
Well, in this particular instance, yes, that's the equation, right? I mean, it depends on the shooter when they shot the ball. So, as for example, when we did the marble experiment, it happened to be, what was it, 74 centimeters to desk, right? But what happens if I put a book on top of the desk and then you shot off of there. Your equation changes. Right? So all we're saying for this question, this particular time when this person shot the ball, that's the equation that modeled that path of that ball.
But like I'm saying for the plus 1.5, the last thing, is it a coincidence that that's the same height that the ball is thrown from, or is it
Nope.
supposed to be like that?
It's supposed to because when D was 0,
Okay.
right? H is actually 1.5, so it's not a coincidence. Good question. So let's go off and plug this in. So D is equal to minus B plus or minus the square root of B squared minus 4AC all over 2A. So D is equal to, B here is my positive 2, so we got minus 2 plus or minus the square root of 2 squared minus 4A here is negative 0.25, and C is 1.5, all over 2 times 2A, which is negative 0.25. Okay, so plug that in the calculator. Who's got an answer? So sorry, D is equal to what?
-2 plus minus 4.
Okay, who just worked that whole thing out for me?
I don't know what to do though.
You don't know what to do? Do you want me to do the steps?
4 plus 1.5
So minus 2 plus or minus the square root of, well, what's 2 squared is 4.
plus
4 times 0.25 gives me negative 1. So negative 4 times negative 0.25 gives me positive 1. Times 1.5 gives me a positive 1.5. Yes? All that divided by
1 over negative
negative 0.5. So D is equal to minus 2 plus or minus. So 4 times 1.5 is 6. So I want the square root of 6 all over negative 0.5. So D is, well, so what's the square root of 6?
I don't understand what you did though.
Sorry?
Why'd you multiply 4 and 1.5?
Oh, sorry, it's 4 minus 1.5. I forgot the minus sign here. You're supposed to catch that.
I did. Why did you?
4 plus
I'm
1.5.
sorry.
That's why I hate the quadratic formula.
Why does it turn out to
So what's 4 plus 1.5?
5.5?
5.5. So we need the square root of 5.5.
I got
Did you get it on test one?
You're
Happy it's over?
2.34%.
Wasn't that bad?
I
So square root 2 plus or minus square root of 5.5 divided by 0.5. So what's the square root of 5.5?
2.34
2.34
to the nearest meter 2.
all over 0.5.
But I don't understand it. What do you round it to? Do you always round it to the 100?
For here, I would probably go to 3 significant digits. So 3, so it's 3, 4, it was 2, 3, 4, 5.
Yeah.
Yes. Or do you go to the nearest
That way you get a little bit more accurate. I'm gonna work up here. So D is equal to minus 2 plus 2.345 over negative 0.5. So that's D is equal to 0.345 divided by negative 0.5. So that should give me like negative 0.69. Right? The other answer we have is D is equal to negative 2 minus 2.345 divided by negative 0.5. So that's negative 4.345 0.345 divided by negative 0.5. So D is equal to roughly 8.69. But we want round to the nearest tenth, so that's really 8.7.
So how do we choose which one to use for the answer?
Has to be positive.
Positive.
Well, look at our axes, right? It's got to be positive here. Right, so therefore, 8.7 meters.
I messed up.
Okay? So here it's just a matter of, recognizing that we have a quadratic equation and we're solving for it. It's equal to 0. So we just want to find the value where it's intersected because that's where it hit the ground. So it hitting the ground, it's nice, easy question, right? It's almost like solving for the intercepts and roots. Next question.
I don't understand you at 8.7.
You don't understand how I got 8.7? Where did you get lost?
Okay, I understand that you're dividing.
Are you okay up to this point? We get D is equal to negative 2
Yeah.
plus or minus.
Just there's all that stuff.
So what's negative 2 minus 2.345? Take out your calculator and do that.
2 minus, I understand that, I just don't understand like.
So
what-
negative 2.
Yeah.
So that gives me negative 4.345. I still need to divide by negative half. So that gives me 8.7.
You're supposed to multiply it.
No, that's my answer, 8.7.
And I was like, like, if you divide it by negative 0.5.
Yeah, it's both same as multiplying by 2.
Yeah.
Divide by half is same as multiply by 2. So that's how I got 8.7. Good enough? So on the test, you would have a calculator. Just do that calculator. Hint. Question is asking for a nearest tenth of a meter. Quadratic. You're using the quadratic equation, right? I mean, that's the only place where you can get some decimals. Okay, so that's sort of a hint when you want to try to apply the quadratic equation. Okay, now the next question is find the horizontal distance now when the basketball is 4.5 meters above the ground. Now, how do we often solve that?
H 4.5.
Dale, so what are we gonna say?
Oh,
Yes.
I was looking down.
Okay, so here we want to hide the ball, so H, so we get out, instead of the H value being 0, right, it wasn't told in the first part H is 0, it's just implied, in and around H is 0. Here we're actually given H is 4.5 is equal to negative 0.25 D squared plus 2D plus 1.5. So how do we go solve that now? How do I figure out what value of D will make this equation true?
Minus 1.5? What's that?
You guys hear what Christian said? So how are we going to solve for this then? I'm going to solve for D. How do I find what value of D is going to make this true?
Plus 1.5. Isolating D.
Isolate D. It's 1.5.
Sorry?
Subtract 1.5 from both sides.
Subtract 1.5 from both sides?
Yeah.
So that gives me 3 is equal to negative 0.25 D squared plus 2D. How's that going to help us?
Then you can take out the 2's, divide by 2.
Divide by 2. Well, we got that squared that's messing us up, right?
Unsquare it.
Michael?
You wouldn't bring the 4.5 across.
We don't bring things across in math.
Like, would you add, subtract? Would you subtract 4.5?
Yeah, so we just subtract 4.5 from each side.
Why would you subtract 4.5?
Oh,
So it's just 0.
so you get negative 0.25D squared plus 2D minus 3. Now you're solving for this quadratic equation. Plug in, using our quadratic formula, plug in the numbers. So So here we're gonna have 0 is equal to negative 0.25. What am I doing? D is equal to plus or minus the square root, no, B, I can't remember the formula. D is equal to minus B plus or minus square root of B squared minus, what's going on? Minus 4AC all over 2A. Okay, so we're just doing the same thing again. So B again was in this case D, so we have negative 2 plus or minus the square root of B squared, which is 4. 4 times A, which is still negative 0.25. So that gives me a positive 1, and the value of C this time is negative 3. So 4 minus 3. All over 2 times A, which is still over negative 0.5. That looks like it's too nice.
It is.
B is 2, so it's 2 squared is 4. Negative 4 times A is still negative 2, so that means positive 1 times C here is 3. So this is negative 2 plus or minus square root of 1 all over negative 0.5. So negative 2, no, we messed up here somewhere.
I got
Jordan called it. That's what I got.
I got x equals 18.
No,
I think it's plus 3 though.
X plus 3. What you doing?
No, we're subtracting 3.
That's
Yeah,
minus
but
3.
it's, no,
So
it's
negative
minus
point-
Oh, is it,
it's
is it negative 0.25? Or
It's
that,
plus
I think I
three.
just wrote it wrong. Yeah, no, it's
No,
it's
that's
minus
right.
3.
It's plus
It's
three.
minus 3. I just did it wrong. My bad.
That's
oh, because
positive.
when you do 4 times whatever, you have 1.
It's 4
Dude,
times
eight-
negative
eight times-
0.25.
0.25
positive.
time minus 3.
No,
Yeah,
Oh, that's right.
that's right. That's right.
No, it can't be.
Yeah, it's right.
Okay, anyways,
So
let's
let's
go
make
on.
extra sheet
So
for
2 plus or minus 1. Oh, divide by negative 0.5. Oh, both answers still negative. Okay. So here D is equal to negative 2 plus 1 divided by negative 0.5. Or D is equal to 1, sorry, negative 2 plus 1. Well, we did plus 1 already, minus 1 over 0.5. So here, D negative 2 plus 1 gives us a negative 1 over negative 0.5. So that gives us D is equal to 2. And here D is equal to negative 3 over negative 0.5, which gives us D is equal to 6. So here we got 2 positive, that's what I was looking for. Here we got 2 positive values for D. Does that make sense?
Yeah, because 4.5 can be reached on both sides.
Yeah, so if we go back and look at our parabola, right, it's kind of small now. 4.5 could be roughly around here. Well, let's say there, right? So what that means is that it hits 4.5 meters as the ball is going up, and as it's going across, it's gonna, as it's falling down, it hit 4.5 meters coming down. So at what point is it 4.5 meters coming down? How far is it away from the person shooting the ball? Yeah, 6 meters away. So that's what the 6 means. At D equals 2 meters, the ball's still going up at 4.5 meters. Okay? So basically, this is just an application of using quadratic formula to solve equations
So,
in a word problem.
so for B, the 2 correct answers would be 2 and 6.
So there's actually 2 points where the ball was 4.5 meters above the shooter.
And what's the distance from the ground to the vertex?
We don't know. I never asked.
You said it travels 4.5 and then 4.5. I don't understand.
Well, if I'm
4.5
shooting
is the height.
5, right? If I'm shooting the ball, right, it's going up. So at 2 meters away from me, it's 4.5 meters high. but still going up at that point. So when it's coming down, it's gonna cross 4.5 meters again, right? So that happens when it's 6 meters away from me. So even by looking at this question, where does it reach the vertex?
Wouldn't be 4.
What's the axis of symmetry? Yeah, the axis of symmetry is 4. So we can actually go off and find what the vertex is here. But that doesn't ask. That's actually a part C I could ask. Ooh, awesome.
'Cause I was just
How
kind of,
high does the ball reach and at what point?
I was just kind of confused because I thought that was the zeros for a second, but it's actually
No.
when it's 4.5 meters
Yes.
off the ground. Okay.
But because they're both the same level, right, we could get the axis of symmetry. Right, which goes back to, man, was that like unit 4? 2 units ago? That's when we developed why x-intercepts were so important.
That works.
Okay, any questions about this question? Guys want to try this on your own?
Yes.